Welcome to SanfordFlipMath. This is AP Calculus. This is an actual extra review video for Chapter 2, the Limits chapter, 2.1 through 2.4, and this is again following the Finney, Demana, Waits, Kennedy book. And really what I'm doing here is just working through the practice test that I typically use with class, and I'm breaking this up into 3 separate videos. So this video is just going to deal with 1 through 6, which is some basic limit computation kind of problems. And so this should be a fairly short one, and we'll go from there. All right, so number 1, which is this one, shockingly enough. These are stolen fresh off the test, just copied and pasted in. So what we're doing is the limit as x approaches 3 from the left of 15. Okay, now really, if it's just a constant in here, if this part right here is just a constant, then the answer just is that constant. Conceptually, what's going on here is if I graph y equals 15, as x approaches 3 from the left, the y value is just riding on 15. So there's nothing real deep going on here, but that's what it means. Okay. Number 2, limit as x approaches 2. If the function, if this y equals x squared minus 3 doesn't have any goofiness going on at 2, then I can just substitute. So if it's continuous, well, this is a parabola. There's no goofiness going on. And so I can just substitute in 2 squared minus 3, which is 4 minus 3 equals 1. Okay, so again, I can just substitute in. It's just keep in mind if it makes the equation undefined, or if there's some weird domain issue, then we have to backtrack. Okay, and just a quick little, what does this mean? Here's the parabola, and all this is saying is as x approaches 2, which would be somewhere around here, as I approach 2 from the left and from the right, I'm approaching that same value of 1. So this would be like that ordered pair 2, 1 on the graph. Okay, so what is y approaching? 1. Okay, all right, next up. The limit as x approaches negative 2 from the right. Okay, so remember that little plus sign on there means from the right. And if I just substitute in negative 2, this is going to be negative 2 minus 5 over negative 2 plus 2. This is negative 7 over 0. Now, I know some of you are tempted to say, oh, look, it's over 0. That's undefined. Well, that's true that it's undefined. However, that's not what y is approaching. This is the answer for y, but that's not what y is approaching. So this really doesn't work. If the denominator ends up 0, then you really have to come up with another plan. And so we'll do that other plan now. Generally, what I would try next is a graph. And the graph for this is going to look something like this. And, oh, is that right? Sorry, I'm thinking in my head as opposed to thinking somewhere else, I guess. Okay, and so as x approaches negative 2 from the right, well, this is the x approaches negative 2 from the right. It is approaching negative infinity. It's going down, 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 farther down. Okay, okay. Now, the next question is related to this. Okay, so this would have been what, number 3? So the next one's number 4. We're talking about that same graph again, and so the idea is, well, from the right side we already said it was approaching negative infinity. From the left side it's approaching positive infinity. Okay, so again, from the left it's going to positive infinity, from the right it's going to negative infinity, and the issue here is they don't match. And so this particular one does not give us a side, a left or a right. So this is actually a two-sided limit. And for the two-sided limit to exist, the one-sided limits have to match. So again, this one's going to positive infinity, this one's going to negative infinity. They don't match. So this limit does not exist, again, because the one-sided limits don't match. Okay, and generally I like to have a little note explaining what's going on here. Okay? All right, I want to pop down to the one below it, actually number 6, because it's related to that same equation again. Okay, and so what I'm going to do is, now please note that this says as x approaches infinity. Well, x approaches infinity to the right, so it's like out here. Okay, And so this graph, if you continue it to the right, the question is, what is y approaching? Well, if I look at the graph, if I play with the calculator, I can get it to kind of show me that it looks like it's getting closer and closer to 1. But again, and I know we've talked about this at length, and we talked about this at the beginning of pre-calculus, so you can match up those x's. So it's like this x is an end behavior model for the numerator. This is an end behavior model for the denominator. So this ends up being an end behavior model for the whole thing, and so it ends up being 1. So because you can reduce x over x. 3 over 3 is 1, 7 over 7 is 1, etc. Okay? All right, let me pop back to what I believe is number 5. Okay? And the idea here again, if I try and substitute the -2 in on the top and on the bottom, what ends up happening with this thing is I end up with 0 over 0, which is technically indeterminate. Now, again, that's what y is. That's the y value. In other words, there is no y value at exactly -2. But again, the limit doesn't say what is y. It says what does y approach? What is it getting closer and closer to? Okay, so there are a couple ways to do this. What I'm going to do is, let's take a look at the graph first and just see, okay? Okay, so I'm going to pop over to the calculator, and here it is. That's not the calculator. Let's try it again. There we go. I've already entered in the equation. Probably worth noting that this equation is lit up, and this one is not. So what it's going to graph is y2 and not y1. Okay, and let's just hit graph and see what we got. It looks a lot like a line to me. Let me pop back over again just for a second. As x approaches -2. Well, x approaches -2 somewhere in that region. Okay, so I think what I'd like to do is get a little more clear view. I'm going to do zoom decimal just because, for a number of reasons. And so here's x equals -2. So that's going to be the point right there. And do you see the point that it is? Yeah, I don't either. Let's do just a little bit of tracing. Okay, and we're going to see. It's funny that I'm highlighting or annotating the smaller view. Sorry about that. Okay, so at x equals -1.9, the y value is -2.9. Okay, let's go just a smidge closer. The y value disappeared. But that's not a surprise because it makes it undefined or indeterminate. -2 makes the denominator 0. And now the y value is -3.1, so on either side of that point, it looks like the y value is trying to be -3. Okay, so based on the graph, so something like this. Okay, so I'm going to say -3. Now, I know some of you are sitting back there already going, come on, Mr. Sanford, you could just factor that sucker. Yep, let's do that. Let's factor it. Okay, so in the top, I'm going to do, well, at the bottom is obviously x plus 2. In the top, x plus 2, x minus 1. Okay, so, oh, I know I'm looking at the wrong spot on the graph. Sorry, I put that in the wrong spot. Okay, let me fix that. Sorry about that. Okay, so it's actually this. All right, so here's that point, -3. So this point's at -2, -3, and that y value is 3. All right, so back to my factoring and all that stuff. Goodbye to goodbye. So this is the same thing as then the limit as x approaches -2 of x minus 1. And now I can just take that -2 and put that in there, and that equals -3. So now I can substitute, now that I got rid of the denominator. Okay, so just a quick little recap. For limits, generally we try and substitute. If there are no problems with the equation there. No problems with equation. Okay. if we can't substitute because it makes it undefined or square root of a negative or some crazy thing like that, then you might look at a graph. Or you might do some algebra and then substitute. Okay, so those are the basic go-to equation, go-to plans for that. Okay, all right, well, I'm going to let this video stand, and what we've done is 1 through 6 from the practice test for sections 2, 1 through 4, and for AP Calc, and thanks for watching, and there'll be more on the next video if you choose, and thank you much. Bye-bye.